This page starts the solving of equations. Make sure that we check for extraneous solutions. So the first thing is we want to isolate the radical. So that's your first step, is always to isolate that radical. So basically I'm going to deal with anything outside what's underneath the radical. So this says 3 plus the square root of 2x plus 3. So I'm going to minus 3 on both sides. So that gives me the square root of 2x plus 3 equals 5. Okay, so once you've done that, the radical is isolated, you can square both sides. So I have 2x plus 3 equals 25. And then we're going to solve. Squaring the square root canceled it, and then the 5 squared is 25. Now we're going to solve for x. So minus 3 minus 3 goes away. That gives me 22. 2x equals 22 divided by 2. X equals 11. So now we're going to plug it back in. You have to check these for extraneous solutions. So I'm going to do my check right here. Check just means to take the value that you got for x and plug it back into the original equation. 3 plus the square root of 2 times 11 plus 3 equals 8. Okay, so we could put that whole thing in the calculator. So I'm going to do 3 plus the square root of 2 times 11 plus 3. That equals 8. 8 equals 8. Check. We are good to go. Same process. So we need to isolate. This time we have the cube root. So I'm isolating everything under the cube root. So the first thing I'm going to do is minus 1. 24. So the next thing I want to do, I'm going to rewrite cube root of x plus 1 to divide by 3. So I have the cube root of x plus 1 equals 24 divided by 3 is 8. Okay, now this one's cube root, so we're going to cube both sides now that we have it isolated. So the cube root of x plus 1 cubed, that means these cancel each other out, so I just have x plus 1. And then 8 cubed, so 8 to the power of 3 is 512. Minus 1, x equals 511. Now again, you've got to check to make sure it works. So we're going to plug it back into our original equation. This is our check. So 3 cube root of x, which we found was 511, plus 1 equals 25. I'm going to plug in the left side of the equation into the calculator, 3, and then cube root, remember, is under math. 511, oops, plus 1, arrow out, plus 1, enter. That gives me 25. 25 equals 25, so check, that works. Okay, next one, same process. So be careful, this 5 minus 2 times the square root of x equals 3. So I need a minus 5 on both sides first. So negative 2 times the square root of x equals negative 2. Then I'm going to divide by negative 2. So the square root of x equals 1. I'm going to square both sides. So x equals 1. I'm going to check by substituting back in. So I've got 5 minus 2 square root of 1 equals 3. I'm going to plug the left side of the equation in. 5 minus 2 times the square root of 1. That gives me 3. 3 equals 3. So that works out. Okay, moving on. Okay, this has the square root on both sides, so there's nothing I need to isolate. So I'm going to go ahead and square both sides. Remember, squaring gets rid of that square root, so I have 3x equals x plus 6. I'm going to go ahead and solve this. Minus x on both sides. 2x equals 6 divided by 2. X equals 3. Make sure you check them. I know we haven't had any that were extraneous, but you have to check them. So the square root of 3 times 3 equals the square root of 3 plus 6. You put this in your calculator, do it in your head. 3 times 3 is 9. Square root of 9 equals 6 plus 3 is 9. Square root of 9. We know the square root of 9 is 3. 3 equals 3, and it checks. Okay, again, isolate first. So I have that 2 on the outside, so I'm going to divide by 2. So the square root of x plus 2 equals 9. I have it isolated, so I square both sides. X plus 2 equals 81. Subtract 2. X equals 79. Check to make sure that the solution works. 2 square root of 79 plus 2 should equal 18. Plug that into your calculator. 2 square root of 79 plus 2 gives me 18. 18 equals 18, and that one checks out too. Okay, moving on. Now this one's a little more difficult, and this one won't be on the test, but it's good for you to know how to do this one. So I have x isolated. The first step is to I have the square root isolated. Square both sides, which gives me 3x plus 7. Well, x minus 1 is the same thing as x minus 1 times x minus 1. Okay, so I would have to FOIL this. So that's going to give me x squared minus x plus 1, which is going to give me 3x plus 7 equals x squared minus 2x plus 1. Alright, now we've got to solve this equation. So I'm going to move everything over to the right side. Minus 7, minus 7. So it's going to give me 3x equals x squared minus 2x minus 6 minus 3x. So that's x squared minus 5x minus 6. Okay, and we know, and that's going to equal to 0. Alright, we know that this is a quadratic, which means I have to factor this. My factors would be multiples of negative 6 that add up to negative 5. So that's going to be negative 6 and positive 1 equals 0, which will give me x equals positive 6 and x equals negative 1. Now we've got to try those out to see if they work. Running out of room here, so I'm going to put this on a separate piece of paper. So we have to make sure both of them work. Alright, so the first one is the square root of 3 times 6 plus 7 equals x, which we said is 6 minus 1. Alright, let's solve that. The square root of 3 times 6 plus 7 gives me 5. 6 minus 1 is 5. So that one does work. So we have 5 equals 5. Let's try negative 1 to see if that one works. The square root of 3 times negative 1 plus 7 equals negative 1 minus 1. So on the left side we have second square root. 3 times negative 1 plus 7. That gives me 2. Negative 1 minus 1. If you're not sure, put it in the calculator. It gives me negative 2. 2 does not equal negative 2, so this one does not work. So this one is an extraneous solution. So we're going to mark through that one. That one doesn't work. But the x equals 6 does work. Okay. Let's keep going. 51, isolate and check. I'm going to start to go a little faster. Minus 6, x minus 3 equals 6 divided by 2. Square root of x minus 3 equals 3. Square both sides. X minus 3 equals 9 plus 3. X equals 12. Okay, let's go ahead and check that. So 2 times the square root of 12 minus 3 plus 6 equals 12. Plug that right into my calculator. 2 square root of 12 minus 3, arrow out, plus 6 gives me 12. 12 equals 12. Check. Okay, minus 8. 3 square root of x equals negative 6 divided by 3. Square root of x equals negative 2. Now you should be able to say to yourself, the square root of any number can never be negative, so this is going to be extraneous. If you don't recognize it at this point, go ahead and square both sides. X equals 4, and substitute back in. I have 3 square root of 4 plus 8 equals 2. 3 times 2 plus 8 equals 2. So that's going to be 6 plus 8, which is 14, equals 2, which we know is not correct, so this is an extraneous solution. Okay, moving on. This one's already isolated. I'm going to go ahead and square both sides. It's going to give me 64 equals 2x over 5 times 5 on both sides. That's a cameo of Chi-Chi. Okay, so times 5 on both sides is going to get rid of this. 5 times 64 is 320 equals 2x divided by 2 on both sides. So x equals 160. Okay, so now we're going to check that. So 8 equals the square root of 2 times 160 divided by 5. I'm going to put that whole right-hand side this time of the equation in the calculator. I'm going to do second square root, and I'm going to do alpha y equals, because I want it to look like a fraction. So 2 times 160 all over 5. It gives me 8. 8 equals 8. That one checks out as well. Okay, keep going. This one's already isolated. So I'm going to square both sides. X plus 15 equals 49. Minus 15 on both sides. X equals 34. I'm going to check. Square root of 34 plus 15 equals 7. The square root of 34 plus 17. 15. Square root of 34 plus 15 is 7. 7 equals 7, so it checks. Alright, again, when you have this 2 minus 9 times the square root of negative 3x plus 5, you want to subtract the 2 first. And I have negative 9 square root negative 3x plus 5 equals negative 18. I'm going to divide by negative 9 on both sides. So that gives me the square root of negative x, 3x plus 5 equals 2. Now we can square both sides. That gives me negative 3x plus 5 equals 4 minus 5. So it's going to give me negative 3x equals negative 1. Divide by negative 3. X equals 1 over 3. I'm going to check. So I have, I'll kind of write this on the side. 2 minus 9 square root of negative 3 times 1/3 plus 5, and we want all of that to equal negative 16. So I'm going to put that in the calculator. I have at least the left-hand side. 2 minus 9 times the square root of negative 3 times alpha y equals, because I want it to look like a fraction, 1/3, arrow out and close my parentheses, plus 5. And we want all of that to equal negative 16. Oh, it equals negative 16. Negative 16 equals negative 16. So it checks out. Last one. I have everything's isolated and I have cube root on both sides. So I'm going to cube both sides, which is going to give me 5x plus 2 equals 4x plus 8 minus 4x. X plus 2 equals 8 minus 2. X equals 6. I'm going to check to make sure that that works. So, cube root of 5 times 6 plus 2 equals the cube root of 4 times 6 plus 8. Left hand side, remember under math is your cube root. 5 times 6 plus 2. That gives me an ugly number. So let's look at what just 5 times 6 plus 2 is. So it gives me the cube root of 32. Since it gave me a decimal, I'm going to go ahead and just work it out this way. So I have 4 times 6 plus 8 also gives me the cube root of 32. So they check out. So that's how you solve. Isolate, and then you're going to square or cube or whatever the index is, both sides, and then you have to check to make sure that it's not extraneous. Just a quick note on extraneous solutions. If you were to look at this graphically, a equation that looks like a square root that looks like this, where it's never going to cross the x-axis, that's going to be no solution. So that's what no solution would look like. Okay. Also, if you were to be able to see it ahead of time, we know that the square root of x cannot equal a negative number. So that would be the other way that you would see it. If not, plug it back in. When you have something that does not equal itself, then we know that it is extraneous. Okay, the last thing is to find the inverse. We know that to find the inverse, we're going to write y equals 3x cubed minus 2. You're going to switch x and y. That's the first step. So switch x and y. So x equals 3y cubed minus 2. And then you're going to solve for y. This is how you find the inverse. So now we're going to just solve. So plus 2. So I have x plus 2 equals 3 divided by 3. X plus 2 over 3 equals y cubed. We know if you get rid of the y cubed, you're going to take the cube root of both sides. So that gives me h inverse of x is the cube root of x plus 2 over 3. Okay, the next one is find the inverse again. Same thing. Y equals square root of x minus 2 plus 1 is on the outside. So x equals the square root of y minus 2 plus 1. And then we're going to solve for y. Okay, so minus 1 on both sides. So x minus 1 equals the square root of y minus 2. I'm going to square both sides. And then on the left-hand side, I have, if you can FOIL this as x minus 1 squared, which is going to give me x squared minus 2x plus 1 equals y minus 2. I'm going to plus 2 on both sides. That's going to give me x squared minus 2x plus 3 equals y. So this is going to be x squared minus 2x plus 3. Again, finding the inverse, same thing. Switch x and y, solve for y. Alright, worked this one out already. So again, switch x and y, solve for y. So m inverse of x is the square root of x plus 2 over 2. And then the last one, go ahead and work that out. Okay, when you work the last one out, that should give you x minus 2 over 4, all cubed plus 5. Remember, on the actual review to receive full credit, I want to see the work for that one. Okay, so let's look at composite functions. So the way you're going to do is you're going to work the inside out. So it says 4 into g. So that means anywhere I see in g of x, x is 4. So that's where I'm going to start. So I'm going to start with g of 4. So that gives me negative 2, 4 cubed plus 5. I'm going to work that out first. I'm going to put that directly into my calculator. Negative 2 times 4 cubed plus 5. Okay, that gives me negative 123. Okay, and now they want me to put what I solved for g of 4 into k. So I have k, I came up with negative 123. So anywhere I see x and k of x, I'm going to put 2 over 3 times negative 123. Plug that into the calculator. Math, y equals 2 over 3 times negative 123. Excuse me, negative 82. That's your final answer. Now the next one's a little more complicated because it doesn't have a value for my x, but it's the same thing. I'm going to take f of x and I'm going to put it into h of x. Okay, so f of x is x cubed minus 3x squared plus 8. So I'm going to take this entire thing and I'm going to put it in here where x is. So 2 times, instead of x, I have this whole function f of x. X cubed minus 3x squared plus 8 plus 1 all over 3. Now this can be simplified. I can distribute that. This is my first. 2x cubed minus 6x squared plus 16 plus 1, because that's on the outside, all over 3. And then that simplifies to 2x cubed minus 6x squared. These guys can go together. So plus 17 all over 3. You could break that up, but I'm going to leave it like this. So h of f of x equals this whole thing. Alright, and then the last thing that's not on your review, but I just want to make sure you understand because this is on the test. If it says, is f of x the inverse of g of x? So that means that I need to prove two things. I need f of g of x, and I need g of f of x. If these equal x on both sides, that means they are inverses of each other. So let's start with the first one. So I have g of x, and I'm going to place it into f of x. So instead of x squared plus 1, I have the square root of x minus 3 squared plus 3. Okay, I took g of x and I placed it into f of x. Well, the square root of x minus 3 squared is just x minus 3 plus 3. These cancel, so I just have x. So this one checks out. The goal is to have x on both sides if they're inverses. So then the other side, I have f of x, so g of f of x. So I'm going to take f of x and I'm going to place it into g of x. So I have the square root, instead of x, I'm going to use my function x squared plus 3 minus 3. Well, these cancel each other out because 3 minus 3 is 0. So I have the square root of x squared. The square root of x squared is just x. So I have x on both sides, which means they are inverses of each other. So that is on the test, but it wasn't on the review, so I want to make sure you understand that. So both of these have to equal x in order for them to be inverses of each other. So the answer would be yes. I have x on both sides. When I do f of g of x and g of f of x. That's it.